So friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your CBNST class, and that has been the class which has been the computer based numerical and statistical technique we have to discuss here. We go ahead for the next question here. The first question of the session in the CBNST, that has been class is your 13th class, and which we have to discuss here. So we had done your 12th classes, and the name of the unit we have, that is the computer arithmetic errors and roots of equation. Here we had done even though more than 42 questions. Here we will discuss more on in this class. And we are dealing here, and that has been we are dealing the regular falsi method. We are using that as well. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So we have your question here. Find the root of fx equals to e power x minus 4x is equals to 0 using regular falsi method. Correct up to 3 decimal places. So we go ahead for the same. F of x is equals to e power x minus 4x equals to 0. F of 0 is equals to f of x, where x equals to 0 is equals to 1, and f of 1 is equals to f of x equals to 1, which is equals to e power 1 minus 4, and that has been equals to minus 1.281718. So here, since f0 f1 is less than 0, then take x0 is equals to 0 and x1 is equals to 1. So for iteration 1, we have for iteration 1, x2 is equals to x1 minus x0 upon fx1 minus fx0, which is fx1. So 1 minus 0 upon minus 1.281718 minus 1 minus 1.281718 equals to 0.438266 that we have here. That will be having answer. So for the same, for fx2 equals to x equals to x2, which is equals to 0.43826 equals to e power 0.43826 minus 4 into 0.43826, and that has been equals to 0.203047. So here, since fx0 fx2 is less than 0, so root lies in the interval that is been 0 comma 0.43826 8266 here. So hence we take initial approximation for second iteration as x1 is equals to 0 and x2 is equals to 0.4382266. Now for iteration 2 we go ahead. For that it has been x3 is equals to x2 minus x1 upon fx2 minus fx1 into fx2. When we put the value 0.4382266 minus 0.4382266 minus 0 whole upon minus 0.203047 minus 1 minus 0.203047 equals to 0.364297. For fx3 equals to fx x equals to x3 equals to 0.364297 is equals to e to the power 0.364297 minus 4 into 0.364297 here, and which is equals to minus 0.017686. Here we have x1 is equals to 0, x2 is equals to 0.438266, x3 is equals to 0.364297, and fx1 equals to 1, fx2 is equals to 0.203047, fx3 equals to minus 0.017686. So since fx1 fx3 less than 0, root lies in the interval x1 comma x3, 0 comma 0.364297. Hence initial approximation for next iteration should be x2 is equals to 0 and x3 is equals to 0.364297 here. Now we talk about for iteration 3. So for that it has been, for iteration 3 it is x4 is equals to x3 minus x2 upon fx3 minus fx2 fx3. We find the value of x3 is equals to fx, x equals to x3, which is being equals to 0.364297, and that is being equals to minus 0.017686. For fx2 equals to fx x equals to x2 equals to 0, which is equals to 1. Now for x4 is equals to 0.364297 minus 0.364297 minus 0 upon minus 0.017686 minus 1 multiply minus 0.017686, that is being equals to 0.357966 that we have. So we'll go ahead for fx4 as well. For fx4 is equals to that we have here x equals to x4 is equals to 0.357966 equals to e to the power 0.357966 minus 4 into 0.357966 is equals to minus 0.001447 here, which we have as follows, and that what we have to discuss about it. Now further here we have x2 is equals to 0, x3 is equals to 0.364297, x4 is equals to 0.357966 here. Then next we go ahead for fx2. So fx2 is equals to 1, fx3 is equals to minus 0.017686, fx4 is equals to minus 0.001447 here, since fx2 fx4 is less than 0, so root lies in the interval x2 comma x4, which is being equals to 0 comma 0.357966. So hence initial approximation for the next iteration should be, and that is being x3 is equals to 0 and x4 is equals to 0.357966. Now we go ahead for iteration 4. For iteration 4 here, that is x5 is equals to x4 minus x3 upon fx4 minus fx3 into fx4 here. I'll put the value, we'll find out for that. fx4 equals to fx, x is equals to x4 is equals to 0.357966, which is equals to minus 0.01447 here. Well, we'll go ahead for fx3 here for the same. So that is for fx3 equals to fx, x equals to x3, which is equals to 0, and that is being equals to 1 here, that we have as an answer. Now we go ahead for the next, we talk about it, and that is what we have to talk about here. is for your another one we talk about is your x5, that what we even do have to find it out. So we go ahead for the same. So x5 equals to 0.357966 minus 0.357966 minus 0 upon minus 0.001447 minus 1. We multiply by minus 0.001447 here, and when we'll solve it out further, it will give you the answer 0.3577449 here. So the next we have your fourth approximation to the root. Fourth approximation to the root equals to x4, which is equals to 0.357966, and fifth approximation to the root equals to x5, which is equals to 0.357449 here. So 357, 0.357 here, 357 here. That has been same here for, as you can see. So since 3 decimal digit repeat in the successive approximation, and that the approximation to the root is to correct up to 3 decimal places, we'll have an answer 0.357449. That was to correct up to 3 decimal digit after a decimal point, 3 significant digit after a decimal point. Now we'll go ahead for the next method we have to discuss here, which is being the Newton-Raphson method, and that is of course being important one which we have to consider about it. So we go ahead for the same. Newton-Raphson method. In a Newton-Raphson method, first of all we have to go ahead here detailed, and that's so we have to find it out here, and then when you are going through with this, you have to answer it out as well on a similar way. So first, recursive relation for the Newton-Raphson method is to be given as recursive or relation for Newton-Raphson method is given as, that has been xn plus 1 is equals to xn minus fxn upon fxn. Here it is dash. For better configurations that we talk about it, for better conversions, x0 is selected in such a way which is being as fx0 f double dash f dash 0 fx0 f double dash 0 is greater than 0. So multiple root that can be obtained, multiple root can be obtained using Newton-Raphson method for following recursive relation. Then we have your formula is xn plus 1 is equals to xn minus p fxn upon f dash xn. So here p number of the multiple roots we have, or xn plus 1 is equals to xn minus p minus 1 f dash xn, f double dash xn here. So modified Newton-Raphson method, modified Newton-Raphson method, we have for the same is xn plus 1 is equals to xn minus fxn upon f dash xn f0 x0. Now we go ahead for the questions that we talk about it, and that what we have to solve it out here, and that has been another question. That is the first question of Newton-Raphson method. The question is, find the real root of 2x2 minus 3 sine x minus 5 equals to 0. Correct. Up to correct up to 4 decimal places with initial value of x0 equals to 1 using Newton-Raphson method. So we go ahead here. Fx is equals to 2x square minus 3 sine x minus 5, what it been given in the question. So f dash x, what we'll get, d upon dx of fx, which is equals to 4x minus 3 cos x. For for by Newton-Raphson method, the root will given been alternatively, in that the formula we have here xn plus 1 here. For the same, and that what we have to talk about it. So xn plus is equals to xn minus fxn, and that is been upon f dash fxn. So initial approximation, we have x0 is equals to 1, that has been given. We'll go ahead for iteration 1 here. For iteration 1, it is being, and for that it is your x1 is equals to x0 minus fx0 upon f dash x0 equals to x0 minus 2 की power x0 का square minus 3 sine x0 minus 5 upon 4x0 minus 3 cos x0 will be 1 minus 2 into 1 square minus 3 sine 1 minus 5 upon 4 into 1 minus 3 cos 1, which is equals to 3.322067. Now we go ahead for iteration 2. For that, x2 is equals to x1 minus fx1 upon f dash x1 equals to 3.322067 minus 17.610743 upon 16.239543, which is equals to 2.237631. For iteration 3, we go ahead. For that, iteration 3, x3 is equals to x2 fx2 minus f dash x2 equals to 2.2276223. That is for iteration 3, that has been 223 76. So for the same, we go ahead for iteration 3, and that has been your the value we'll put it 56634 upon 10806029, and that is being equals to 1.991784 here. Now we go ahead for iteration 4 as well. So that is being iteration 4 equals to x4 equals to x3 minus fx3 upon f dash x3, that is being equals to 1.991784 minus 0.196345 upon 9.193119, and that is being equals to 1.970426. So 1.9 here, that is mean write it. Iteration 5, we talk about it. That has been x5 equals to x4 minus fx4 upon f dash x4 equals to 1.970426 minus 0.001539 upon 9.048933, and that is being equals to 1.920970.256. Now we go ahead for iteration 6. And for the same, it is x6 is equals to x5 minus fx5 upon f dash x5 equals to 1.970256 minus 3.5929 into 10 to the power minus 6 upon 9.047783, that is being equals to 1.970256 that we have. So the root is repeating up to 6 decimal places, and hence it is correct up to 6 decimal places here as well. So we go ahead, and that what will be ending it up here itself. Other than CBNST, I am going ahead here in the detail about it. So yes, other than CBNST, we had cover up your many of the subjects, and that what we even do have to cover up in the next coming classes as well. We had done your sociology and software engineering, even though we had done your chemistry for class 12, that is being important for you all, which is of unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9 as well, respectively, with their conversions, logarithms, anti-log with the atomic mass and the molar masses, of course. After talking about that, we had done your software engineering, and we had done your understanding the human being comprehensively, the human aspiration and its fulfillment with your unit 1, unit 2, unit 3, unit 4, unit 5 with their 2 marks possible questions, which we are dealing with. We had done your ER diagrams, we are dealing with English vocabulary as well, and on the same page we are dealing with the reasoning, and we are in the reasoning. We had completed your verbal reasoning, in that we had done general mental ability and the logic reasoning and non-verbal reasoning. We had done cities and logic classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete path and figure matrix, paper folding, paper cutting, tool detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation analysis, and practice question set as well. After talking about that, yes, we had done your many of the subjects related to it, which has been important for you all. In terms of CBNST, we had started with your unit 1, that has been the computer arithmetic errors, where we had done your floating point arithmetic machine Epstein-Rapson round of error, chopping error, truncation error, associative and distributive law error, floating point arithmetic, inherent error, error propagation, numerical instability. In the rules of equation, we had done second method, Newton-Raphson method we had started with. On fixed point iteration model for the simple rules and the derivations of their rules of the conversions, articles, accelerations of conversions, modified Newton-Raphson method for multiple rules, bridge-White method for the polynomial, and Bystrom method for the quadratic factor, computer algorithm of these methods. That's what we have to discuss as well. After completing that, we have to cover up unit 2, which has been the interpolation, which has been we have to cover up the algorithm and the error analysis of Lagrange of the Newton's divided difference interpolation relationship in the various difference operations. And we had done your piecewise linear interpolation, cubic spline interpolation, natural spline, and then we have to do the Chebyshev's polynomial approximation, Langkos economization of the power series, curve fitting, linear and nonlinear least square approximation, third conditioning of the least square least square methods, and gram schematics versus of the orthogonalization, computer algorithm of the least square curve fitting. In unit third, we have to do the differentiation integration. In differentiation, we have to cover up the method based on the interpolation and the finite differences, and which Richard and extrapolation as well. In integration, we have to cover up the error analysis and the trapezoidal and Simpson method, Newton that course integration method, Gaussian integration method, Gauss-Lagrange method, Lobato integration method, and the Radau integration method, error terms in the integration method as well. Same case for unit 4, that solution of simultaneous linear algebraic equation. We have to cover up the Gauss elimination method, third conditional system, conditional number, successive and the relaxation method, rate of the conversion, solutions of the ordinary differential equation. Here we have to cover up the single steps method, Runge-Kutta method, second order method, third order and the fourth order method, and multi-step method, predicator corrector method as well. In statistical technique, we have to cover up the statistical hypothesis, test of hypothesis, type 1 and type 2 errors, level of significance, test of involving the normal distributes as well. So here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe to our channel so that many and maximum people can get the information at once. And even though you can also enjoy the video as well, and you will get all the videos here, and whatever we are uploading here, whatever the subject you had requested for, we will surely be uploading you for your sake. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.